Next, we're going to look at an application of linear equations, linear functions. So in the year 2000, the U.S. federal debt was $5.7 trillion. In 2010, it was $13.6 trillion. Treating the year as the input and the debt as the output, find and interpret the slope of the line through these 2 points. Then find an equation for the line through these 2 points, letting x equals 0 represent the year 2000. Okay, so it's very common on applications, instead of using the years themselves to measure from a particular year, like we're measuring from 2000, so 2010 would be 10. Okay. So if we want to find the slope, we need 2 points, and that's basically what we have in our first couple of sentences here. We have the point 0, $5.7 trillion, and then we're going to have the point 10, $13.6 trillion. And so we can find the slope as y minus y over x minus x. So we subtract our y values, and you could add on all the zeros if you wanted, although that's a lot of zeros, so I'm going to use the actual numbers and just note that I'm measuring in trillion dollars. So my change in y will be 13.6 minus $5.7 trillion. I'm going to write the units here so that we can see what happens with the units on slope and how we can interpret that. And then my change, whether I use the years or the 10 and the 0, my change in years is going to be 10 on the bottom. We either have 2010 minus 2000, or if we're measuring from x equals 0 being 2000, we'd have 10 minus 0. And so that winds up being 7.9 divided by 10, or 0.79. And if you look at the units, it's trillion dollars per year. Okay? So if you want to ever want to interpret slope, look at the units. On top, you have the units for y. On bottom, you have the units for x, or whatever your input and your output are there. So we wind up with the units on y per the units on x, which in this case is trillion dollars per year, which gives you your interpretation. The debt's going up by $0.79 trillion per year on average using this data. If you converted, that's $790 billion per year if you don't like the decimal point there. And so we have 2 points, and we want to find the equation of the line. We need the slope, which I found. I could then use point slope in either of these points, or y equals mx plus b. We can plug in m in either of the points and find the b value, but we actually know the b value already here. It's easier than that. You know, if we do y equals mx plus b, we need the slope and we need the y-intercept. Well, the y-intercept by definition is the value when x equals 0, and in this case x equals 0 is the year 2000, and that value is 5.7 trillion. So using those units, I have the equation of my line is y equals mx plus b, 0.79x plus 5.7, where x is the number of years since 2000, and my output is in trillion dollars per year. Okay, let's look at one more slide on this video. Horizontal and vertical lines. Okay, special cases. So slope. As slope gets steeper, my graph gets steeper. As slope gets larger, my graph gets steeper, either in the positive or negative direction if we look at the absolute value of the slope. Horizontal and vertical lines are like the 2 extreme cases. We're going to look at what happens here and also generalize the results, including slope. So we could make tables to plot these. So if we want to graph y equals 7, I could make a table with as many points as I want, but for every single point, y equals 7. We could have different x values, and I've done -2 to 2 here, but the y value would always be 7. If you plot those, you're going to find all of your points have the same height. You get a horizontal line if you fill through. So y equals a constant is always going to be a horizontal line. And to compute the slope, you can take any 2 points. I've taken the ones at 0, 7, and 1, 7 and compute my slope. You get your y minus y is actually 0 because both y values are 7, and divided by whatever points I picked there. If I did 1 minus 0, I'm dividing by 1. So whichever points I pick, I get 0 on top when you have y equal to a constant. So my slope is going to be 0. 0 divided by 1 is 0. So to summarize that, y equals k, for some constant k, is going to be a horizontal line, and the slope is 0. What about x equals a constant? X equals -3. I can make a table. I can't pick any x values I want, though, because x equals -3, but we could have any y values we want. So again, I've taken -2 to 2. If I plot those, if we always move -3 in the x direction, we wind up on a vertical line through x equals -3. So x equal to a constant will be a vertical line with an x-intercept at that constant. And the slope, you wind up getting 0 on the bottom, which is undefined. You can't divide by 0. So if you want to see that, pick a couple of points. Again, take maybe the easier ones where you have 0 and 1 as the y values. So my change in y would be 1 minus 0. My change in x is going to be 0. -3 minus -3 is 0. If your x's are constant, you're going to get 0 on the bottom when you divide, which is undefined. So horizontal lines, the slope is 0. Vertical lines, the slope is undefined.